Theorem 6.3.1. If a line is drawn through the center of a circle perpendicular to a chord, then it bisects the chord and its arc. Theorem 6.3.2. If a line through the center of a circle bisects a chord other than a diameter, then it is perpendicular to the chord. Theorem 6.3.3. The perpendicular bisector of a chord contains the center of the circle. Figure 6.39 illustrates Theorem 6.3.3. Given, in Figure 6.40, circle O has a radius of length 5. Segment OE is perpendicular to segment CD at B, and length OB equals 3. Find length CD. Solution. Draw radius segment OC. By the Pythagorean theorem, length of OC squared equals the length of OB squared plus the length of BC squared. 5 squared equals 3 squared plus the length BC squared. 25 equals 9 plus the length BC squared. BC squared equals 16. BC equals 4. According to Theorem 6.3.1, we know that length CD equals 2 times the length BC. Then it follows that length CD equals 2 times 4, giving us length CD equals 8. In this section, we assume that two circles are coplanar. Although concentric circles do not intersect, they do share a common center. For the concentric circle shown in Figure 6.41, the tangent of the smaller circle is a chord of the larger circle. If two circles touch at one point, they are tangent circles. In Figure 6.42, circles P and Q are internally tangent, whereas circles O and R are externally tangent. Definition. For two circles with different centers, the line of centers is the line or line segment containing the centers of both circles. As the definition suggests, the line segment joining the centers of two circles is also commonly called the line of centers of the two circles. In Figure 6.43, line AB or segment AB is the line of centers for circles A and B. A line segment that is tangent to each of two circles is a common tangent for these circles. If the common tangent does not intersect the line of centers, it is a common external tangent. In Figure 6.44, circles P and Q have one common external tangent, line ST. Circles A and B have two common external tangents, line WX and line YZ. If the common tangent does intersect the line of centers for two circles, it is a common internal tangent for the two circles. In Figure 6.45, line DE is a common internal tangent for externally tangent circles O and R. Line AB and line CD are common internal tangents for circle M and circle N. Theorem 6.3.4. The tangent segments to a circle from an external point are congruent. A belt used in an automobile engine wraps around two pulleys with different lengths of radii. Explain why the straight pieces named segment AB and segment CD have the same length. Since the pulley centered at O has the larger radius length, we extend segment AB and segment CD to meet at point E. Because E is an external point to both circle O and circle P, we know that length EB equals length ED and length EA equals length EC by Theorem 6.3.4. By subtracting equals from equals, length EA minus length EB equals length EC minus length ED. Then, because length EA minus length EB equals AB, and length EC minus length ED equals length CD, it follows that length AB equals length CD. To complete this section, we consider three relationships involving the lengths of chords, secants, or tangents. Theorem 6.3.5. If two chords intersect within a circle, then the product of the lengths of the segments, parts, of one chord is equal to the product of the lengths of the segments of the other chord. In figure 6.50, length HP equals 4, length PJ equals 5, and length LP equals 8. Find the length PM. Solution. Applying theorem 6.3.5, we have length HP times length PJ equals length LP times length PM. Then 4 times 5 equals 8 times length PM. 8 PM equals 20. Length PM equals 2.5. Theorem 6.3.6. If two secant segments are drawn to a circle from an external point, then the products of the lengths of each secant with its external segment are equal. Theorem 6.3.7. If a tangent segment and a secant segment are drawn to a circle from an external point, then the square of the length of the tangent equals the product of the length of the secant with the length of its external segment.